everyone, and welcome to String Methods in Java. So to start with, I want to do a little bit of reading. I'm going to send you the docs for Java's string method, or string methods. Let's take like 4 minutes, read through this. Scroll through like the methods and stuff at the bottom too. Go.
Kyle, I'm sorry, my speaker wasn't working. What are we doing?
I posted a link in chat. Take a couple minutes, read through that.
Thank you.
I'm assuming you want us just to read that first part?
Nope, whole thing. Make sure you look
Okay.
through the methods and stuff also.
Okay, cool.
All right, let's chat a little bit. Anything interesting you found in that?
Some of the methods are also used in JavaScript, like trim, uppercase, lowercase, join,
Yep.
length.
Lots of the same stuff. Great observation. What else?
Strings are constant. Once they're created, that string value can't be changed.
Yeah, can't change an existing string. That's different
Yeah,
from
that
JavaScript.
it did. Yeah, that jumped out when I was reading that.
Yeah, fascinating, right?
So I didn't get super far into the reading, but I had kind of a question on
Yeah.
that. So if it's an empty string, does that mean it's always going to be an empty string?
Yep.
Oh, okay, cool.
Now you can like base another string off of that, but you can't mutate that original string. Other things that you found interesting in that reading? Another one that I find kind of interesting is that a string is just a sequence of characters. Might have autopiloted over that one, but this is that first point that they were making. That declaring a string like this, the way that we normally do it, is exactly the same as doing this. Making an array of chars. Notice that these are single quotes, not double quotes. Single quote is how you do a char literal. Making an array of those and then passing them into the string constructor. And that's really why they're called strings. It is a string of characters. It's kind of like an array. And then we can do stuff with all of those. Interesting. Okay, cool. So there's 3 things that I want to hit on in particular. So we'll talk about comparison. I want to talk about building. And I want to talk about formatting strings. So put in less objective terms. I hope that by the end of this lesson, each and every one of you will be able to compare strings, build strings, and format strings. All right, so let's start with comparison. This one isn't difficult, but it's something you need to be on the lookout for. Because if you haven't already, you are going to make this mistake approximately 1,000 times. If I have some string, I can't compare it like that. Does not work. Who can tell me why?
Because the string is an object?
Because the string is an object. Why can't I compare objects like that? Man, nobody? All right. So, let's talk primitive and reference types. I've seen a lot of good definitions for these in vocab. What's the difference between a primitive type and a reference type?
A primitive type will fall under the category of like number, Boolean, whatever those basic building blocks are. A reference type is something that we've defined as a type.
That's like 80% of the way there. So
Reference,
things that we didn't define, like string. String is a reference type. We didn't define that.
The primitive type is built into the system that you're using.
Strings are also built into the system.
The reference type means it's addressed, like it has to do with the address in memory.
Yes! Bingo, bingo, bingo. So a primitive type, anybody who is in the thing we were talking about, memory registers yesterday. So imagine the memory on your computer is a bunch of little blocks like this. With a primitive type, the value actually goes like directly in there. So when you work with primitive types, you're working with that actual value. We can compare primitive types. This is also the case in JavaScript. Strings were primitive in JavaScript. They're not in Java. So we could do string comparisons with like double equals all day long in JavaScript. What we couldn't do a double equals comparison with was objects, because objects are reference types. With a reference type, you have like the data stored somewhere, and then these memory registers, they don't actually have the data. They point to it. So you go, oh, I'm storing this array over here. Points to it. Which means that something else, if you try to copy that variable somewhere else, it's still pointing to the exact same thing. This string, I can have two variables that aren't pointing to the same value. They're pointing to the same like object. In code, that looks like this. All right, nothing up this sleeve, nothing up this sleeve, empty folder. I'm going to make a string practice application.java file. Feel free to do the same. Doesn't matter what it's called. And over here, I'm going to make an entry point. So I'll say this is a public class string practice application. And then I'm going to make a public static void main method that takes an array of strings called args. All right, so now we're in Java land. So if I make some string and I make some other string, even if it has the exact same content, those are pointing to two different locations in memory. So if I do if some string equals some other string, let's see, system.out.println oops, this was okay, so here's my little program to prove this. I made two strings with the same values, compare them, let's see if they match. So I Java-C my Java files, and I Java... Ooh, it matched? Come on, dude. Don't make me look dumb in front of my friends. Oh, you know what it probably did? It probably like did something in the compiler that like made those point to the same thing. Anyway, point still stands. This is not the way that you compare objects. Who can tell me how you do compare objects?
Oh, equals.
Equals. So the correct way to do that is like that. Still work? Still works. Anytime you have to compare two objects, every object has a built-in equals method. That's the thing that needs to compare it.
Why doesn't it give you an error? It gives you an error on everything else.
Because we very well might want to check that something is the same reference. We might want to do something like verify that these are actually pointing to the same object. In which case, yeah, that's what double equals is for. If we want to check that they have the same values, that's a different thing. But yeah, that's how you figure out whether or not something is pointing to the same location in memory. That's double equals. And that's like a useful thing. Maybe that is what you're trying to do. The other 99 times out of 100, you probably want to use equals. Other questions about that? All right, so when we compare something, we want to use dot equals when we want to compare two objects. Still do numbers that way, still do Booleans that way, that's fine. Booleans and numbers are all primitives. But otherwise, dot equals, or this is like a really handy thing that's built in. If we go down the methods, equals ignore case. That's pretty slick. Cool. Onward. Building strings. So since strings are immutable, we figured that out. We can't just like plus equals to build up a string. Not how we're supposed to do that. So the other thing that we don't want to do is make a bunch of intermediate strings. So here's what I mean by that. Instead of doing something like some string is hello, and then this is that. So what I don't want to do is make 3 separate strings. Oops, come on. And then try to concat them together like that. That sucks. Don't do that. So instead, what we do is use a string builder. Let's see. Java string builder. So we make a new instance of this, And then if we go down to the methods, these append methods, that's what we use to build the string. So instead of doing this, we'll say that string builder hello world is new string builder. And we can like kick it off with something too and say hello. And then we append to hello world. Like that. And then the method for like flattening it is, anybody remember it off the top of their head?
It's toString.
toString, there we go. So then our string full hello world would be hello world to string. You may guess why this matters. Why that, oops, why that is better than that. No guesses even?
It's because like you're leaving a lot of artifacts with the first one.
Yeah. And like also using up a lot of space. Objects aren't free. So it always like costs something to make a new instance of an object. So we try to avoid doing that when we can. And so this one makes one object and then just works with that object. And then when we want to pull the resolved value out, it only has to do the expensive part once instead of 3 times. Questions about building strings? The fuck is calling me? All right, let's take a look at our last one. So to build strings, shush. This one was string builder and toString. Last one, formatting. So this one we generally use a static utility for called string format. So this one's actually part of this same like string methods thing. Static methods, there we go. Returns a formatted string using that thing. So it takes in a string and then an object. Psst, the object is a string. So what that ends up looking like, all this, is we do something like string.format. So this is going to return a string. There's 2 parts of this. The first is a string representing like what the template for it looks like. And then the second one is any variables that we want to put in there. So like if I say hello, and then I think it's that, and then I give it another string, let's see what happens if I print line that. dope. This is the same thing as template literals in JavaScript. Serves the same purpose. Anytime you have to mix and match variables and strings, use string.format. Don't just jam a bunch of things together with string builder or something like that. String builder is good if everything that you're putting into that is a string already. If you have to put the value of a variable in something, that's string.format.
So one of the best things about those template literals is that we could take data from anywhere, a bunch of different data, and throw it all into one string. How is it that we can have that same power here in Java, where we can take a bunch of different data and put it in a bunch of different times?
Like that.
Perfect. And so that's always going to correlate. Your first %s goes to the first thing after the comma. The second one goes to the second thing, so on and so forth. So order is going to matter heavily.
Correct.
Great.
Like so.
Awesome.
So that %s, it's because it's a string. If it's something else, like a float, it's that. If it's an integer, it's that. There's a list of all of the things. Let's see. Java string format. There they are. These are like the different types that you can interpolate in. Can't do anything. Can't be a cat object. How? It's got to be one of these kinds of things that we're trying to put in there. Trying to get the cat's name? Oh, well, that's a string. Nope, strings, numbers, booleans, and time, actually. And that is how you format. Questions about any string-related shit? Cool. I hope that each and every one of you can compare, build, and format strings.